Well, welcome everybody to the May 2020 Central Arkansas Astronomical Society meeting. We're meeting on Zoom. We've tried the platform for a few practice runs, and we tried it last month as well to see how it worked. Zoom appears to be the easiest for us to use, and we're also able to use it for even live viewing. We did a moon session recently, and before that, an impromptu deep sky session. So it works. And tonight we've got Michael and Rocky are going to talk about globular clusters. So we're going to run through their presentations, and we'll see how the technology holds up to get it done. And we'll also record this so that people can watch later. We do have a Zoom license, and we can host more than enough people once we do these as more regular methods of meeting. So I will turn it over to our presenters unless there's anything else that needs to be brought up to the group.
Okay. Well, Rocky and I talked. I'm going to start it off. So I'm going to share my screen and then shift to the PowerPoint. So I'm going to talk about a little bit about one of my favorite things to observe over the years, and that's been globular clusters. They're amazing, and they actually look like what they're supposed to. I don't know how many times, especially this time of year, you go out and you see all these galaxies. They're wonderful. There's tons of them, and you look at them, even in my 8-inch scope, they look like a little smudge. So that's why I like always looking at them. They've never let me down. So for those that don't know, I've started a little introductory. The globular cluster is just a large group of old stars, closely packed, symmetrical somewhat. And because they have that spherical point, that's why they're called globulars. And that definition comes from the Encyclopedia Britannica. So here are two of my favorites, and one of my ones I always go back to is Messier 22 in Sagittarius. It's big from the Earth. It's almost the size of the full moon in terms of its dimensions when you see it in your telescope. And these things are old. They're among the oldest stars in the galaxy, 12 billion years or so. And they're large, 50 light years for Messier 22, and Messier 13 is a little further away, but it is 84 light years across, and they're just beautiful. And they won't look like what I show you here, but you will see the individual stars when you're looking at anything from a 4-inch telescope and higher. So current theories are that the globulars formed within several hundred million years after the Big Bang. And basically, these localized concentrations of matter began to condense into galaxies, and that these globular clusters formed around with them. And that's what that first wave of globular clusters, they call them the real old ones, that's when they seem to have formed because of their age. We don't know exactly how they formed, but most computer models said they formed like small little spheroidal, ellipsoidal galaxies. And so a lot of people study globular clusters to try to understand how the spheroidal galaxies formed. And a lot of people also look at them to see and understand how matter interacts with dark matter, because again, they believe that dark matter interactions would help develop and lead to the formation of globular clusters. So the ones that these old first wave GCs, their stars are metal poor, and then when the star formed, 98% of the matter in the universe was hydrogen, and it's still about 90% of everything, and the rest was helium. So there were no heavier elements, and so they have a metal index that's low. They're metal poor is what they call them. So the second wave, there was a second wave of formation, is after the galaxy started to form, they kicked off as they condensed, and some people think it may have been reverberations from the supermassive black holes that were starting to form in the galaxies. They sent shock waves through the galaxy, and that started another wave of globular cluster formation, basically large star formation. some of the initial stars that formed were very large. They burned through their hydrogen, then helium, and then even oxygen really fast. Supernova cost out a bunch of metals. And then these globular clusters form the second wave. They're more metal rich. And so a little thing at the bottom, a little by the way, each of us contains trans-oxygen elements. So we're made from remnants of supernova. So we got star stuff in us, which is pretty cool when you think about it. So the structure of the globular clusters there's over 200 of them in the Milky Way, and they are surrounding, they form basically the galactic halo. So if you look at this edge-on diagram of our galaxy, there's the disk, there's the sun's location, and these things are located all the way around. And there's just tons of them in terms of originally formed, and there's only about 200 left. Sometimes people believe as they move through the galactic center, the supermassive black hole that will grab it, that's Sagittarius A, and just suck it in, and they're formed there, and we lose some of them as time goes by. Some of the initial models believed that the globular clusters helped form these supermassive black holes. But the newer models they run say, no, they formed at the same time. And so the globular clusters did not contribute to galaxy formation, but were part of the galaxy formation. And so I stole this diagram from Rocky just to show you that plotting the positions of the GCs on the side view, they are part of that spherical halo. I think this shows it better than another diagram because it's a little further out. Hang on a second, that just advanced on me. So you can see that big mass there. And another one I stole from Rocky was this one, and that shows the Andromeda galaxy with all of its globular clusters noted. And a lot of them they have. Globular clusters were found to be globular clusters because of their spectral patterns and their radial velocities and relative to the galaxy. So they're able to show that, oh yes, that they are really globular clusters. They have a lot of Cepheid and other variable stars that they use to designate their distance, and that helps show the distance of the galaxies that we're looking at. So they play a very important role in early astronomy, understanding the massive size of the universe and understanding how these galaxies move through space and everything like that. So good stuff. I think they're one of the most beautiful objects to observe. Again, I recommend using a 6-inch or larger scope. I always start low power and then ramp it up, get up to 200 to 300x, and then you just start seeing more and more stars across it. And you see beautiful colors in there. You can see red, yellow, blue, and others. Now, when you want to see more stars, you kind of have to use the averted vision trick. But unfortunately, as you all know, when you do that, when you look off, and now you're looking with your rods, and those are black and white only. So you lose the colors, but you pick up more stars. Here's one of my favorite fields. I love this. And there you see Antares, and you can see the little nebula that's associated with it. And then there's M4. One of the easiest globular clusters to find. Just look at Antares at low magnification. There's M4. And then when you have a big enough scope, you'll see NGC 6144 all in the same field, and it is just pretty to look at. And it's coming up soon because we're moving into the summer constellation soon, and you'll be able to see that. So I recommend highly taking a look there. So most globular clusters can be found easily by star hopping. Most are pretty bright. I tend to use setting circles. And of course, they now have the go-to systems. If you have those, obviously that's it's a no-brainer getting through. If people want to learn how to use the setting circles, some people I mentioned setting circles, they look at me like, what are those things? Most scopes come with them, and if anyone doesn't know how to use them, I'm sure there's, besides myself, there are others in the club that'd be glad to show people how to use them. Good star charts are needed for the star hopping, and one of the best ways of getting that is a nice book. I downloaded it a couple of years ago. It's called A Year of Star Hopping by David Hearn, And it's an ebook, and it's got wonderful, wonderful star charts to find many different objects, not just globular clusters, but nebula and elliptical galaxies, open star clusters, and those are all printable. So you can print the charts out, take them out with you when you go to observe, and star hop to your heart's content. So it's not always easy to determine visually if a cluster is a globular cluster or an open cluster. And one of the best examples to see that is the comparison here is M71 in Sagitta. It's a very nice globular cluster, but you can see it's kind of loose and it doesn't have the very dense concentration that some of them do. And it's got a very wide range of stars on the outside. And then when you go look and you get M11, a very tight open cluster. And it looks like, oh, that's a globular cluster, but no. And the way they find that out is if you look at the motions, the relative motions of the stars, the open cluster, the stars are moving through space together, but they're not necessarily revolving much around each other. Whereas in a globular cluster, there's a lot of rotational motion, and you can see that things coming towards you, so they're blue shifted, and things coming away from you, and they're red shifted, so this whole mix, and you can say, yes, this is a galactic cluster, globular cluster, all right? Another thing is the stars in M11 are metal rich, whereas most globular clusters, even the second wave ones, are metal poor. So spring and summer are a globular cluster fest. I mean, there are tons of them out there. And it's probably because as we're starting to look back towards the center of our galaxy, as Sagittarius comes around, we can see from our outer portion, we're located on the rim of the galaxy, and we're looking back and we're looking at the galactic halo. The greatest concentration of GCs, the winner, and Rocky's going to talk a little bit about Ophiuchus. It's got 21 globular clusters in it, and a lot of them in Scorpio and Sagittarius. In fact, Rocky and I were talking about last week, one of my little things to do was to try to find all 21 of the globular clusters in Ophiuchus in one night, and that's fun to do. I just bought my first camera, so I'm going to start shooting some, but over the years, I've always drawn them. And I use colored pencils on a black paper, and I do my best to do that. And it's always interesting to compare from maybe 1 year or maybe even 15 years ago when I drew one and look at it again. It's like, oh, I missed that star, or something happened there. It's kind of neat. But I really enjoy doing that. It's very relaxing. So, two of them that tend to be overlooked a lot, even though they are both Messier objects, is M92 and Hercules. And it's probably because it's M13 so close by, and everyone's like, yeah, why go to M92 instead of, just going to M13 right off the bat. But it is one of the oldest globular clusters in the Milky Way, and it's one of the most metal poor, and so it is a very worthy thing to look at and say, wow, that is something. It's one of our oldest set of stars in our galaxy. And M10 in Ophiuchus, it's a really nice globular cluster. Even though it's smaller, it's one of those where it has a lot of loose stars on the outside, so even with a 4-inch telescope, you can see quite a few stars, as opposed to some of them that are so dense in, it's hard to pick out individual stars. So that's nice. So M5 is the brightest globular cluster in the northern sky. But as I said, the southern sky really wins this war here. We've got Omega Centauri, which is larger than, apparent size larger than the full moon. And I saw it when I was down in Costa Rica for my son's wedding. I got up really early and went out and saw it with my binoculars. But a couple of weeks ago when I was at RRO, I took a shot. It's really low, but you can see it. And it's really very, very nice. You don't get a great resolution and everything, but you can see how massive it is. And it was just a pleasure to finally see that and saying, wow, look, with my telescope. So I recommend going after all these and seeing what you can see. Try the highest magnification you can with your telescope and see if you can pick out the colors. Okay. So many nice globular clusters are not Messier objects. The books, if you look at them, you can find star charts and everything to see the globular clusters, the NGC objects, and a lot of them you're like, why wasn't that a Messier object? Well, they didn't see it. So Messier didn't put it in his catalog, and they're really beautiful. You can get the right ascension and declination, and a lot of online sources that'll tell you how to star hop to them. And the August 2019 issue of Astronomy had a really wonderful article about globular clusters and how to find each individual one, what stars to look at to work your way there. And I'll mention that article again later. So here are a few examples of the NGC objects that are particularly nice. Now, NGC 6541, as you see over here, it is in Corona Australis, so it's down in the southern sky, but it's higher in the sky than Omega Centauri, and you can see it. I had no trouble picking it up last year. And the one in Sagittarius, Ophiuchus has got a bunch, Lupus. These are really wonderful globular clusters to look at. Oops. This particular one in Libra, NGC 5897, is a very, very loose cluster. And even with a 3-inch telescope, you're going to see the individual stars. So those of you who have smaller scopes, that's a good one to go for. And as I said, a fun night is trying to get all 21 that are in Ophiuchus, and about a third of them are NGC objects. So, you know, work your way through, try to find them, and compare the different aspects of them. Now, Rocky is going to talk a little bit about this, I believe. They classified globular clusters based on the degree of concentration of the stars towards the core, how densely they are, and then how they spread out. And it's called the Shapley-Sawyer concentration class, or designation class. I'm not going to talk about that here. I'll leave that to Rocky if he has time to do it. You will see these differences when you look at through your telescope. Even in a 3-inch telescope, you'll see these things. Some are more oval than spherical. And with an 8-inch scope and larger, you can actually see substructures within a lot of the globular clusters. For example, in M13, there's the famous propeller. It's a 3-pronged dark area that you can see towards the center of the globular cluster, but you need about an 8-inch scope to see it. Okay. So, as I mentioned and hinted at earlier, globular clusters have real scientific impact. I told you that they study them to understand better how ellipsoidal and spherical galaxies form, because they believe the mechanics and the models, computer models say that they formed in a similar manner. And so these GCs are studied to understand how early galaxies formed and how early star formation occurred. So recent physics and cosmology postulates that dark matter networks are required to condense matter. So by looking at the globular clusters in our galaxy, we have a better way of understanding how dark matter in our own galaxy led to star accumulations and the formation of our own galaxy. The globular clusters are basically a mini model for that. All right. So there's a lot to learn from them. Hopefully what I presented tonight will stimulate your interest not only to observe them and photograph them, but to read more about them. I have assembled about 40 articles ranging from amateur to things that are in the Astrophysical Journal. I still read, I have a bachelor's and master's in astronomy, and so I still try to read the literature, even though I went on to a different field. I went into biophysics as a career. I still love doing all that astronomy, and I'll read those. And some of them are really understandable. You don't have to have a big physics background. So I'm hoping maybe our club will put that on a website so people can go in there and read those articles and enjoy them. And as I mentioned, there's been 2 very recent articles strictly on globular clusters and observing them. It's the one by Amir that I mentioned in August 2019 in Astronomy magazine. And then the June issue, it just came out by Bacchic. It's called Enjoy the Great Globulars. It talks about 20 different globular clusters that he recommends you look at. Tells you how to find them, and gives you a very good description of what you expect to see with different size telescopes. Okay, and with that, I am done. I'm going to return to the main screen here if I can.
All right, thank you very much. That was great. And since we'll have this recorded and we'll be able to also start storing the presentations, it's not just a one-time deal. So we really appreciate it. Rocky's got a presentation also tying into the same subject. So I will mute and let Rocky take over.
Okay. So this is about Ophiuchus, and there's a lot, like Michael said, there's a lot of globular clusters in it, so I'm going to talk about them, a little bit about them too. But first of all, the legends of Ophiuchus. Of course, you know, it's he's a healer and has a snake coiled around him, and it's the only constellation that is the Serpents is actually the only constellation that's split in two. But this is a picture by John Flamsteed in 1729 from his atlas. Now let me see if okay. So the legend of Ophiuchus is, let me talk about that a little bit. Ophiuchus was the son of Apollo and Corona, and while she was pregnant, she evidently had an affair, and a crow took Apollo the news that she had, and instead of rewarding the crow, he turned the crow, which was Snow White, he turned it black. So that's why crows are black. And then he shot Corona. This is pretty gruesome. He shot Coronis with an arrow, but rather than let the child perish, he snatched the unborn baby from her womb as the flames of her funeral pyre went up. And he gave Ophiuchus to a centaur, trying to find his name here. Anyway, he gave to a centaur, and the centaur trained Ophiuchus in the ways of medicine. He trained him so good that he healed almost everybody, and he could even bring people back from the dead. And when Hades saw that he was taken away from his numbers, he sent a lightning bolt to had a thunderbolt. He got Zeus to send a thunderbolt to kill Ophiuchus. And when Apollo found out about this, he was very upset, and he went and he put Ophiuchus in the heavens, and that's why Ophiuchus is in the heavens. So anyway, that's how Ophiuchus made it into the heavens. It's a long. There's a lot more to it than that if you want to read about it. But it was pretty complicated. There's a lot of different ways they tell the legend. One interesting thing about Ophiuchus is it's actually in the ecliptic. And as you can see from this diagram, it spends 6 days in the ecliptic is 6 days in Scorpius and 18 days in Ophiuchus each year. So a lot of people refer to Ophiuchus as the 13th zodiac sign. And here's how it arranges that. The sun is actually in Ophiuchus from Scorpio from November 24th to November 29th, and it's in Ophiuchus from November 30th to December 17th. So I don't know if anybody can answer, but I was going to ask if anybody has a birthday in Ophiuchus. So I guess anybody can answer. So here's a chart of Ophiuchus, and this is from our guide that we have, learning the constellations, and you can get a copy from Bruce or me. Do a little sales pitch. All the proceeds go to either CAS or ASNA, Association of, well, anyway, Dark Skies. But one interesting thing about Ophiuchus, it looks like this star should be in Serpens Cauda, because of the lines drawn. But if you look at the boundary lines, the boundary actually comes out like this. And so actually his right hand is holding Serpent's Cotta right there. So there's a pair of alphas. I can't go back, but here's a diagram. A pair of alphas right here, and one of them is Alpha Ophiuchus, and the other was Alpha Hercules. And Alpha Ophiuchus is Raisal Hague, and the head of the serpent collector. Raisal Getty is Alpha Hercules, the head of the kneeler. Now, I threw that in there because Alpha Hercules is a nice double star. It's a nice pair. You think they'd be in the same constellation, but they're not. But it's a nice double star, so be sure you try to find that sometime. Raisal Getty was really very interesting star too. It's magnitude 2.08, and it's only about 48 light years away. It has a binary companion. It's moving it's basically in the Ursa Major group, and so it's moving in the same direction and speed as the Ursa Major sign. Its own group. It's only 2 times as massive as our sun, but it's 25 times brighter. And something else it does, it spins at a rate of 88.5% of what it would take for the star to break up. So there's a lot of study of this star because of that. It also has interstellar dust between it. It looks, in its spectrum, it looks like it should be a star a lot farther away than it really is. This is a constellation card, and I put it in there because it shows a constellation that is part of Ophiuchus now. And you can see that Ophiuchus is called Serpentarius, and it was called that until mid 1800s by some people. But the constellation I put this in for was Taurus Poniatowski, and Poniatowski was the king of Poland. Back in 1777, it was created, and it's named because the little group here resembles the Hyades, so they call it the little bull. And it's fun to look at it with binoculars. You can see it naked eye in good skies, but it's fun to look at it with binoculars, and it's got some very interesting objects in it. So here it is, a little close up, and you can see the B that looks like the Hyades, if you're familiar with the Hyades. And right here, where I have this little circle right here, is Barnard's star, which is the star with the most proper motion of any star. It's the 4th nearest star. It's the nearest star we can see from our hemisphere, being about six light years away. And it's the fourth nearest star after the 3 components of Alpha Centauri. 2 other objects in it, though, are 67 Ophiuchi, which is a binocular double star, and 70 Ophiuchi, which is a binary star. And it's one of it's a very interesting binary star. First of all, it was discovered by William Herschel, so it's one of the early binary stars and one of the most studied because it's only 16.6 light years away. The 2 components are 4.2 and 5.9, and they have a nice color contrast. And I always like at star parties to show people Albireo and ask them what color they see. Well, here's one that different astronomers have looked at, and they see yellow and red, gold and violet, yellow and orange, and several other colors. So I hope to look that up pretty soon. Actually, Ophiuchi is the moon is just past Ophiuchi now into Sagittarius. So Ophiuchi probably rises before midnight. So we'll be getting to see it pretty soon. The period of this 70 Ophiuchi is a close double. It ranges from 1.2 seconds to 1.7 seconds to 6.7 seconds. And right now, and you can see this chart stops what, about 1930 or something. Anyway, we're coming up to where it's at its widest right now. It's close to that 6.7 inches. So seconds, I mean. So now would be a good time to look at it. I'm looking forward to seeing that next chance I get. Another object that I didn't realize was in Ophiuchus was the Kepler supernova. In 1604 was in Ophiuchus. It appeared in 1604, and that is the last time a naked eye star supernova has appeared in our galaxy. So that's to us at Earth, I mean. So that's over 400 years since we've had one. It's about 20,000 light years away, and if you can see this, this is his drawing from the book he wrote about it, De Stella Nova, and the end right here is where it was down in Ophiuchi's right leg. It attained a magnitude of -2.5, so that was a full magnitude brighter than or more brighter than Sirius, and almost not quite. It's about the same brightness as Jupiter, I guess. Venus gets brighter, but it was about as bright as Jupiter. It also aided Galileo's theory concerning the makeup and location of the stars, and had a lot of controversy because of that. So this is kind of a contemporary star with Galileo also, and they still study the remnant that's left from it. Here's a list of some binocular objects to look at in Ophiuchus and Serpens, M10 and M12 in the same binocular field, magnitude 7.5, M62 and M19. I think those are down near, those are down near Antares, mag 8.0 and 8.5. You look at the diagram of Ophiuchus and you don't realize that it extends all the way down right beside Antares. It's pretty spread out, and even though it looks like a real big constellation, Hercules is the 5th largest constellation, and Ophiuchus is the 11th largest constellation. So anyway, as far as the boundary lines, M5 is the bright globular. I included M5, even though it's not in Ophiuchus, it's in Serpens Caput. And M5, I think Michael talked about M5 a little bit. I've got a picture of it here in a minute. M16 is an open cluster in Eagle Nebula in Serpens Cauda, and Rho Ophiuchus is a triple star near Antares. That's not fun to look at in binoculars and spectacular. I've got a picture of it in the next slide. Spectacular in a picture because of the nebulosity around it, and of course, look at Poniatowski's bull through binoculars. And this is a Rho Ophiuchi by Danny Klippo. Took this picture, and it's a triple star. I'm not sure which 3 stars, but through binoculars, it's 3 stars. I've looked at it several times. Region near Antares, and telescope objects. All the binocular objects are good telescope objects, and the M9, M14, and M107 are a little bit fainter globulars, and of course Barnard's star. And I don't remember. I have tracked down Barnard's star together at one time and sketched it, but I don't remember if it was for an Astro League program or not. let's see, in the Shapley-Sawyer globular classification system, cluster classification was by Harlow Shapley and Helen Sawyer, and it uses Roman numerals from 1 to 12 for a high density cluster down to a low density cluster. Ophiuchus has a good variety, especially when you add nearby M80 and Scorpius, which is another one that Michael showed. So you can see M80 is a very concentrated cluster, and it's ranked as a number 2 on the 1 to 12 scale. M62, which is kind of down near Antares also, I think, is a number 4, which is still a pretty concentrated cluster. You can see M10, see how loose it is compared to the other 2 as far as the central part of the nebula, and M107 is a lot looser, and that's a picture by Chris Lasley, the M107S. And here's M5 is a 5th on the concentration scale. M12 in Ophiuchus is a 9, and M19 is a number 8, and M14, another photo by Chris, is a number 8 on the scale. And some bonus objects are M16 is in Serpens Caput, and that's pretty spectacular. I always find it when I start out with Sagittarius and start up looking at all the objects. There's a string of objects that are going up, but anyway, it's in Serpens Caput, and then M5 again, which is called the Rose Cluster in Serpens Cauda. Now I want to talk some about the AstroLeague program, and that is to observe 50 globular clusters from the list with at least one challenge object, and challenge object might be an 11th magnitude or something like that. They're listed, I think, in the instructions. You can do it, it's a visual observing program. You can use GoTo or digital setting circles, or you can star hop, but it is open to digital setting circles, and I did use digital setting circles to do mine, about the only one I've ever used them for. But it worked pretty good. I did about 45 of them in one night. And so it's kind of like a Messier marathon. It's pretty, I stayed up most of the night doing it, but you have to do it in the summertime, because almost all, about 90% of the globular clusters on the list, you only have to have 50 of them, are in the late spring, summer region with Ophiuchus and Scorpius and Sagittarius, and some, there's some more outside of that. There's some in the spring sky too that are very nice. But you have to do a sketch or something. No, you don't have to do a sketch, I don't think, but you have to record your date, time, instrument power, seeing transparency, and you have to estimate the concentration class for each one. So what I did was I kind of looked up a list and studied that for a while before I ever started. And then it's fun to check it, see what other people have for the concentration after you get done with it. And then, of course, submit to the Globular Cluster Program Coordinator. And if anybody wants to do it, I've got a checklist where you can do your notes and do a sketch if you want to, and record all your other information. And you just print out 10 sheets of paper, and it's got all the information on here, like the size of it, the location. I think that's the magnitude, 2 cons, and so it's got all the information you need on there too. And then as you sketch them, you know you got them. You don't have to go back and look up and see which ones you don't have. So if anybody wants that, I'll be happy to share it with you. And this is a checklist of the objects that we just talked about. So, and one of the ways that I learned the skies was basically when I was a kid, I got a 2.4-inch refractor. And I had a pair of 7x35 binoculars from World War II of my daddy's. And I had a book and it divided out the constellations, and it gave you objects to look at in the constellations. And I'd pick a constellation, and I'd go out and I'd see if I could see all the objects that they listed in this book. So anyway, that's a good way to do it, is pick a constellation and do like Michael said, and go out and get all 21 globular clusters, or get a list of objects for that you want to look at, and go out and look at it. So anyway, that's all I've got. If anybody's got any questions, I'll be happy to answer them, but Michael might be able to answer them better than me.
Rocky, I've got a question. It said, Michael mentioned that sometimes it's hard to tell these from open clusters, and you showed the picture of M107. How did somebody figure out that wasn't an open cluster? Because that's what it looks like just in the picture.
Well, he gave a real good, is he still on?
I am.
Yeah, didn't you say that globular clusters kind of rotate, and so you get a red shift on one side and a blue shift, so you can tell that way, and the other way is that, and I didn't realize that until you talked about it a minute ago. And,
well, it's not one side or the other, but they do show stars that are not just moving away from us, but are coming towards us because they're rotating around the common center of gravity. Whereas an open cluster tends to move uniformly in a linear manner.
Right. So that's one way.
Yeah. The other way is that the globular clusters are very metal poor, and they're very old stars, billions, 11 billion years or older, whereas a lot of the open clusters, when they put the age on the stars, they're just millions of years old. So that's another way, by age.
I think M71 that you showed, I think it's in Sagitta, is people tend to go back and forth on that one. Is it globular or open cluster?
Yeah, they went back and forth for a number of years, but it was about 8 years ago they got more precise measurements on it and said, no, it is a globular cluster.
Good deal, yeah.
Are there more questions? Rocky, I think you're still sharing your screen. There we go. Does anybody else have questions?
Yeah, I had a question for Michael. You had mentioned some of those oldest clusters are metal poor, but if the stars are that old, why aren't they producing metal as they age?
Well, remember, a star can only produce metal up to about oxygen. All right, it'll start to oxygen, it'll grow carbon, and then it'll go oxygen, and it has to collapse. It can't fuse anything more. So the heavier elements, all the elements past oxygen, have to be produced in a supernova. So they've had supernova over the years, but there hasn't been a lot of new star formation in globular clusters. There's been some. They find some younger stars in there, but the vast majority of them formed 11 or 12 or a billion years ago, and they just did not have metals in them.
Okay.
Yeah, so that was actually my master's thesis, was the production of transferic elements in a type 2 supernova within the first 47 milliseconds.
Okay, do you want to send us a copy?
You're welcome for it.
Okay.
Thank you, Rocky, and thank you for Michael. Those are great presentations and a lot of practical advice on how to go out and have fun observing too.
Yeah, we could do a globular marathon sometime and do a night where we just do globular clusters and earn the merit badge or earn the Astroleague award.
Yeah. I think you can do that one with a remote telescope too, or photographically, so you could use the remote telescope. And I don't know if you have to observe more than 50 or not.
You know, they've changed. I think they might have changed that some since I've looked at it, because they went back and added to where you could take pictures of them.
Mhm.
You know, image them. A lot of them.
Yeah.
I'll check it right now while you're finishing up.
Well, I always, like I said, I always try to encourage the younger astronomers to go look, when they go to start doing MSAI objects, go after the globular clusters first, because they actually do look a lot like what they're supposed to be. Whereas if they start out trying to go after some of these, you know, very dim galaxies, you know, because galaxies are exciting, but really, I mean, you look at some of them with a 3 or 4 inch telescope, you're like, yeah, okay, I give up. And even some of the nebula, except for, you know, Great Orion Nebula and a few others, there's not much there. But globular clusters always seem to come through.
Okay, you can image all of them. You can image all 50 of them now. So you can use imaging too.
Mm-hmm.
So that would be a great way to practice using the RRT if you wanted to give it a shot and didn't want to have to put a lot of equipment together on your own.
Yeah.
Yeah, and remote telescopes are allowed also. It's got both that and
Not like the old days, huh, Rocky?
No, they upgraded about 3 or 4 years ago. They upgraded all the programs and decided which ones they wanted to allow imaging and allow remote scopes and stuff. I've had several people do remote scopes, and including Bruce and Jeff Robertson on Variable Star Award.
Oh, wow. All right.
I just mention for anybody wanting to use the RRT for globulars, the resolution on that camera is so low that you're just going to get a lot of blobbiness.
Oh.
So you're better off using the RRT. You can get some of the big galaxies, or nebula look fine because they're fuzzy anyhow. But if you want pinpoint stars, you're not going to get it with that camera.
On the subject of cameras, there was a little email traffic a few minutes ago about, you know, we have these sub lists of the club email list, one of them for the board officers, and somebody suggested that we put one together for electronically assisted astronomy, and wanted to see if there's interest in that. I think Jim can set that up fairly simply just by putting people's email address in a cluster, and those would receive any messages sent to that common email address. Jim, is there a preferred method of getting people to sign up for that?
Just email me, or and then I will set it up.
Okay, that's great. So that's if you're interested in the electronically assisted astronomy group, email Jim and let him know that you're interested in that, and he'll get that set up. That's what we've used over the last few weeks to do one impromptu session of deep sky that Danny ran the telescope on, and then Chris ran the telescope on the moon session. And Rocky was able to annotate the images and narrate, and even was able to put up a sketch right next to the live photograph of an area that we were viewing. So that was impressive. It seemed to be the same scale too. That was amazing. Well, do we have any other business we need to take care of while we're all on? Well, thanks to everybody. Chris, you've got us facilitated for having these meetings with Zoom, and thanks, Michael and Rocky, for the presentations. They're really great, and science to actual observing. So that's, we had the whole thing, and a little bit of mythology thrown in.
Yeah.
So
that was good. I like the mythology.
Really good.
I've read a couple of different legends before, but that was a good one. Good story, Rocky.
Yeah. Thank you.
No, I don't think, Rocky, you're not old enough to have lived back through the mythology, are you?
Almost.
Almost.
Feel like it sometimes.
all right. Well, again, any further business for us to do tonight?
Well, I just wanted to get from Rocky. Rocky and I were talking. I didn't realize he was a fellow Italian American. Rocky, how do you say your last name?
Well, I say it Togni, and we say it over here Togni, but over there they say Tony.
Yeah, that's what I was going to say. Is Tony or Tony?
Yeah.
Yeah, that's what I was wondering. Yeah.
All right. Well, I guess we're adjourned then. Thank you, everybody.
Mm-hmm.
Have
Bye.
a good month until we convene again for the regular meeting. Thanks.
All right. Take care, everyone. Clear skies.
Yeah.